Hi everyone, I'm Adam from Applitools, and today I'll talk about how to effectively test your responsive apps and sites, which is a challenge that, at least in my experience, many teams struggle with. So the session is going to be somewhat advanced. We're going to spend a few minutes explaining what responsive websites are, and then we're just going to jump directly into code and build a complete test for github.com. We'll share best practices and tips along the way, and of course there'll be time at the end for answering your questions. So let's start. What is a responsive website? If we look at the Wikipedia definition for a responsive website, we'll see that it's an approach to web design that is aimed to provide an optimal viewing and interaction experience across a wide range of devices. But in order to understand exactly what that means, it's best to look at a responsive website and see it in action. And we'll be looking at github.com, and right now you can see how it is laid out optimally for a very wide screen. Now you can see that at the top we have a navigation bar that allows, with a few navigation buttons that allow us quick access to all the important pages of the site. Above the fold we have the main purpose of the site, which is to call users to sign up. We even have room for a complete sign-up form. And below that, you can see the benefits of using GitHub that are arranged in a single horizontal row of boxes, which make use of the abundant horizontal space that's available. Now, if I'll start to narrow the width of the browser, you can see how the boxes become smaller and smaller, and the images are smaller, and there is less room for the space. But at some point, the site switches the layout to a point where the boxes are laid out in two columns, which is more suitable for this form factor. If we look at the top, you can see that we still have room for the sign-up form, but the navigation bar is gone. There's simply not enough room to place it there, and so it's replaced with a navigation menu button or a hamburger button that if we click it, it allows us access to the navigation buttons. Okay, and if we continue to narrow the site, you can see that we can get to a point where the sign-up form completely disappears, and the boxes are laid out in a single column. So this is a very nice example of a responsive website that adapts its layout to be optimal to any form factor that you throw on it. Okay, so just like we saw in this example, the main factor that determines the layout of a responsive website, and it's true for github.com and for the majority of sites, is actually the available width. When we're talking about a web application, it's actually the width of the viewport of the browser, which you can think of as the width of the browser minus the borders of the window. Now, the value of this width is available to you. You can use it in your Selenium tests via the inner width property of the window JavaScript object. So enough with the slides, let's start testing. As you all know, every test consists of interactions that provide input to the application and then validations that verify that the resulting output is correct. And at this point, we'll just focus on the interactions and we'll leave the validation for later on in the talk. Now, I'm going to code with C#. I'll use NUnit to organize the tests and execute them, and I'll use a WebDriver to drive the browser. Now, the reason I'm using C# is that first, it's my favorite programming language, and I'm the speaker, so I get to choose. Second, there are not enough examples with C# and WebDriver, so this is my small contribution. And third, it's very similar to Java, so I'm sure that you'll all be fine following the example. Okay, so what you see right now is a test class. It's called GitHub Tests, and it's marked as a test suite. With NUnit, this is called a test fixture. Yeah, the font is big enough. We have our WebDriver instance. Before every test that is being executed, we have a setup method that is being called, which instantiates a local Chrome driver. And whenever we finish a test, there is a teardown method that actually closes the browser. And the test itself is very simple. What it does is that it navigates to github.com, which gets us to this page. Right? Then it locates the personal navigation button by its class name and clicks it. which basically means that we click this button over here and move to the personal page. And then we locate the open source navigation button and click it, which gets us to this page. So basically, we are just visiting 3 pages. Remember, we just deal with interactions at this time. We don't do any validations. OK, so before we execute this test, we need to specify the width for the browser. After all, we are testing its layout, so we don't want any arbitrary size for the browser. We want to test specific layouts. And what we'll do is that we'll allow passing it as a parameter. So let's say I can specify the width over here to the test fixture, and I want it to be applied on the browser, so on the WebDriver. So the way that we do it with NUnit is that we'll add a field to hold the width. And then we'll add a constructor that will take that width, the parameter, and set it on that field. And then after we create our Chrome driver instance, we'll just set the browser size. With the width that we have and 600 pixel height. It doesn't matter what number I use here because it doesn't affect the layout. So now I can run my preliminary form of a test and see what we get. So you can see that the browser is starting. It is resizing. And we have the home page, moving to the personal page, and then moving to the open source page. Very easy. Now let's try and just run it on a different layout mode. Let's try an narrower form factor, let's say 800 pixels, and see what happens. So the browser will start. We have the resize. And the test crashed. You can see that the test has failed. And if we look at the report here at the side, we can see that we have an exception. It happened when we try to access the personal navigation button, and we have an element not visible exception. Okay, so let's try to figure out why that happened. If we go ahead and narrow the width of the browser to 800 pixels, you can see that in this layout mode, the navigation buttons are gone, as we saw in the beginning. And this is why our test failed. So, but what we have instead is this hamburger button, the navigation menu button, that we need to click, and then we have those items available. If we'll inspect those elements here, for instance, the personal page, we can see that it still has the same class attribute and the same class that identifies it, just like we used to identify it in our test. So what we need to do in order to write our interaction code in a way that would be generic and would work for all the different layouts is basically to write a utility method that knows how to click buttons, but take into account the different layouts of our application. And it can do it exactly as we described by looking for the presence of this button over here. So let's inspect it and see how we can detect it. We can see that. Okay, it's gone. We can see that it has a class attribute, and this is the class that identifies it, Octicon 3 bars. And so we can write this utility method, let's call it click navigation button. It will take a locator for the button that we really want to click. But what it will do, it will look for that navigation menu button by using a driver find element by class name, and this would be the class name that we just found. Then we'll check if this button is displayed. Right? If it is displayed, it means that the other navigation buttons are not displayed. So we need to click it first, so they will be accessible to us. So we can just click it if this is the case. Now we know for sure that our navigation buttons are available, so we can just find whatever button we're trying to locate and click it. So now we can modify our test to call click nav button with its locator, with the personal button locator, and over here as well. For the open source button. And now we can run our test on both form factors, and it should work. Let's run it and see what we get. OK, so the first test kicks in. We have the first resize, 1,000 pixel wide. No problem clicking the personal button and the open source button. And next, with an 800 pixel wide browser, we just click the menu button and then click the navigation buttons. And this is great. Both the tests has passed. And what's nice about it is that we now have a generic test that works for all the different layouts and performs the interactions with one code. Now, of course, there are many of you that have noticed that there is something terribly wrong with this implementation, which is the fact that we have page implementation details inside our test, right? This is really bad because if we have 1,000 tests and we would just change the implementation of the website, and we have 1,000 tests to update. So we want to have this type of change done only in one location that encapsulates the implementation of the page. And for this, we have the page objects that I'm sure that you are all familiar with. And what we're going to do now is simply re-implement the same exact logic as page objects. And basically, what we get is that we have a base page that is common to all pages. It is extended by our home page, personal page, and open source page. They all pass in as part of the constructor the driver that they got, and also some human readable description of the page, such as open source, personal, etc. Now, the base page itself, as usual, contains the common parts, like the different locators that we are using, the navigation, the personal button, the open source, and the hamburger button locator. And it also has some methods that provide common functionality around for all these different pages, such as moving to the open source page. You can do it from any of these pages. And the way that you implement is that we call our click navigation button method with the locator for the open source button. And it will take care of clicking that button. And then it will create the open source page and return it. And the click navigation button is implemented exactly like we implemented it before. There are no changes here. But once we did that, we can rewrite our test to be much more readable and also to not include any of the implementation details, such as creating a home page, going to the personal page, which returns the personal page, and then going to the open source page. OK? So let's take a look at some of the interaction tips that relate to what we just did. So the first tip suggests that you should detect page layout within its page object. So just like anything that we do with page objects, we have different pages in our application. Each of them can have different layouts and different layout transition rules. So the best place to encode these rules is inside the page objects and not inside your tests. This way, if these rules change in some way, you only need to update the page object, and you don't need to touch your test at all. If you do that, you are able to build browser and layout independent tests or interaction code, just like we did here. All we want is to go to the open source page, and the page itself can understand how to do it based on the current layout of the application. Now, an important thing to note is that you should avoid building a specific page for each layout of your application. The reason is that for the majority of responsive websites and apps, the different layout modes all share the same elements and the same DOM structure. It's not like they have a different implementation for each layout. The only thing that's different is just the styles, the visibility, and the location of the elements. Okay, so basically, if you have a single page object that encodes how to use these elements, how to approach them, how to locate them, and how to operate on them, you can simply have a single page that takes care of all these different layouts. And the Last important thing to take into account when you design those pages is not to rely on the window inner width property. So just like you saw in the test that we just wrote, we basically figure out how to click the navigation button by looking at the presence of another element, the hamburger button. What we could have done as an alternative approach was to look at the inner width and figure out, according to that, at which layout mode we are, because this is what guides the application. But the downside of doing this is that you form a dependency between your test and between your page object and the implementation. So if for some reason someone decides to just change the breakpoint, the transition point between layouts, your test will fail. On the other hand, if you only look at the elements themselves to make this decision, your test will be more robust and it will recover from that change and it won't break. Okay, so now that we know how to write generic interaction code that works for all your different layouts, let's talk about validation. But how can we really validate responsive web design? How can we make sure that our app, responsive app, or site does provide an optimal viewing and interaction experience across a wide range of devices? So don't be shocked, but the solution is visual testing, which is exactly aimed to verify that the UI appears right and correct to the end user. And here you can see, for example, the Twitter application that really breaks on a very narrow form factor. You can see here how the notifications all moved down, they didn't have enough room, moved down on top and overflowed on top of the notifications below them. It looks really bad, but this is exactly the type of things that an automated visual testing can automatically detect. Now, for those of you who are not familiar with these tools, the workflow is very simple. First, you drive the application that you're testing, and you get screenshots. Then the tool takes those screenshots and compares them with baseline images. These baseline images define the expected appearance of the application at each point in the test. Afterwards, when your tests are done running, the tool generates a report that shows you all the screenshots and baseline images and any differences that were found. And then a tester has to look at the report and decide for each change whether it is a bug, in which case he rejects the new screenshots and opens a bug, or if it is a valid change to the application, he simply accepts the new screenshots and they become the baseline images for subsequent runs. Now, we don't have a lot of time in this talk, so you'll have to take my word for it that this type of testing is very effective, it's robust and stable, and you can scale with it. Now, if you don't trust me, last year at the last Selenium conference, I gave a talk that focused on this workflow, so you're free to look it up, or stop by the Applitools booth and you'll get more information about it. But enough with the talk, let's just add visual validation to our test using Applitools eyes. Okay, so you incorporate visual validation by using the Applitools eyes SDK. And the main class that you get with this SDK is called eyes. So let's add a field here to hold the instance of that class. Before each test, we create an instance of the eyes object. And we also need to point it to the eyes server that it is working with. In this case, it is the demo server. Next, we need to set the API key that identifies our account in Applitools. In this case, it's hidden behind an environment variable that is called demo API key. And we also want to validate full page screenshots, entire pages of github.com, not only the screenshots that are available through the viewport, which Chrome gives us. So we ask the SDK to provide us, to simulate those full page screenshots for us. Lastly, as you saw, every time we run the test suite, we have two tests that are running for each of the screen sizes, and we want those to be batched together in the Applitools eyes dashboard. So we'll add a batch object. We'll call it responsive, and we'll add it to as the batch of the eyes instance. Okay. Now, before running a test, we will call eyes open to indicate to the server that we are starting a visual test. We pass in the driver. We pass a name for the application, that would be GitHub, and the test name, which with any unit is available through test context, current context, text and name. The last parameter that we need to pass is the viewport size, the size of the application that we want to test at. And this is the size that we set before as the browser size. We don't need to do it anymore. We let the SDK do it. And what the SDK will do is that it will actually set the size of the browser, so the size of the viewport itself will be that size. Later on, we'll explain why that is very important. Now, at the end of the test, we want to signal to the eyes server that we are done testing, so we'll call eyes close. And now we can add our validations. So once we got to the home page, we want to verify it. So all we need to do is add this line of code. We just need to say check window, and then provide some description. So in this case, I'll send the name of the page. And we're done. This actually takes care of giving you 100% coverage for that page. It takes the full page screenshot, validates it, and if anything changes from the baseline, you'll know about it. It will fail your test. Similarly, when you move to the next page, you call eyes check window, providing the personal page name as a description. And then when you go to the open source page, you just call eyes check window with the open source page name as a description. And we are almost done. We already have complete coverage for these 3 pages. We were done with validation of these pages. But if you recall, on the narrower viewport size, we have those intermediate states where the menu is open. And we want to validate these states as well. Perhaps there's a bug in the visualization of that menu. But we have a problem. We want to have a generic test. Just like we had generic interaction, we want to have generic validation. But how can we have generic validation if we need to validate aspects that are specific to a specific layout? So the solution to that is basically to let the page object itself let us know, raise an event, call a callback method, whatever way you want to think about it, that will let us know inside our test that something changed in the UI. Okay? And when that happens, we can register on that event and do the validation. Okay? So we don't, again, have the time for me to code that. I can show you how it's done in the questions part if you'd like. But basically, once we encode this event, what we can do is just register a callback that takes a description and is fired by the page object itself. And then all it needs to do is just perform another validation point on the current state of the UI whenever this event is fired and provide that description as input. Okay, so let's run it and see what we get. This time we have a generic test that does also interaction and validation. Okay, so GitHub opened up. The SDK is now resizing it, so it will be the exact size of the viewport. And now it starts scrolling and stitching the page and generating that full page screenshot. Moving to the personal page, and then to the open source page. And of course, all those screenshots are not just taken, they're also validated by the server. And now we have the second resize. Let's let it run, and while it's running, let's talk a bit about the tips that are related to validation. Okay, so the first tip mentions that you should set the viewport size rather than the browser window size. In the beginning, we set the browser window size using the driver manage window size. Then we moved it to the eyes SDK. Why is it important to set the viewport size itself? Because when you are testing for layout correctness, you want to test the layout transitions. You want to check the exact points where you break the layout, so you need to be pixel perfect with the width that you set. Now, when you're setting the size of the browser window, you're actually setting a smaller size for the viewport. So it's difficult to figure out what size to set. More than that, if you have a fixed number, you will get a different viewport size on different operating system and different browsers, because each browser has its own Chrome around the viewport that could be of different width, and different operating systems will have different width for the window border. So if you want it to be uniform, which you do because you want to test your site across multiple environments, then you need to set the viewport size. Now, doing that is quite complex, but if you're interested to know how that's done, just go to github.com, look for Applitools. All our SDKs are open source, so you can just look at the implementation and see exactly how to accomplish it, and you can copy it and use it in your test if you wish. Now, let's go back to our tests. They are done. And if we look at the Applitools dashboard and refresh it, you can see that we have our responsive batch, and it has two tests in it that both passed. You can see that one has 1,000 pixel wide viewport, and the other has 800. And if we look at the thumbprints that were of the screenshots that were taken, you can see that the one with the 1,000 pixel wide viewport had 3 validation points, and the other had 5 of them, right? Because we had those intermediate states where the menu opened. Now, if we zoom in on that intermediate step, you can see that it does include that menu, okay? So it gets validated as well. You can also see that we have actually 2 images in each validation point. One is the baseline image, and one is the screenshot that we are validating against it, as I explained before. Now, let's say that we would have a little bit more time, and we could run this test not just on 2 form factors, but on many, and also on different browsers and different devices. Eventually, you'll get a test that would look, be more realistic and have more tests in it and cover more platforms. And let's say that just now, GitHub decided that they changed the color of their logo to green. Let's see this. This is the logo, and they don't want it in black, they want it in green. So basically, all our tests will fail because they're doing a full page screenshot, and the logo appears in all the pages. Now, in this case, we have 19 tests that covered 4 different environments, different browsers, and some desktop, some mobile. We tested form factors of the application, and in total, we got 76 mismatches. So although it's easy to see that in all of them, the change appears where the logo is, still, it could be a bit overwhelming to go over so many of them, and if you have 10,000 of these, of course, there's many more to look at, but luckily, you can ask the tool to just group those similar differences together. So we only see the root causes or the unique representation of each change. So regardless of how many tests we had, we only need to look at 2 of them. If we look at the first one, it's easy to see that the logo did change color to green, which is what we expect to happen. So we can just, with a single click, accept all the occurrences of this change. If we look at the second one, you can see that in this case, there was a bug. The logo didn't change color, it disappeared completely. Okay, and this is a bug, so we can easily reject with a single click all the occurrences of this change and save the entire baseline suite. And you can see that how features like this can help you scale up your tests regardless of the number of tests that you're running. Your overhead, the maintenance overhead will not increase. So let's go back to our validation tips. The second tip suggests that you should use page object callbacks to validate layout-specific UI states, and that's exactly the trick that we did, where the page objects let us know that something changed, and we kept our code generic in that way. Another one is that you should always prefer, when possible, to perform full page validations over component-specific validations. There are 2 reasons for that. First of all, a full page validation gives you more coverage. But second, it requires less effort, both to create it and to maintain it. The reason is that if you're doing component-specific validations, you need to deal with the element locators. You need to find them and do many calls for each individual one. And of course, maintain those locators as your application UI changes, which leads to more work. And lastly, you should always focus on the lower layout boundaries. So you all know that if you have a range of values to test against and you cannot test all of them, it's a very common technique to test the boundary cases of the range. The idea is that this is where you probably have conditions in the system itself under test, and this is where you probably find bugs or implementation mistakes. So if you have to choose between those 2 boundaries of a layout, the lower one or the upper one, always go for the lower one. The reason is that this is the ugliest form of that layout. This is the most crowded and dense form of that layout. And because of that, there is a high chance that you will find bugs there. So just to show you that this is not a theoretical suggestion, if we look at github.com, you can see that for this layout mode, if we start narrowing it down, just a few pixels before the transition, they have a layout bug. And if we narrow it down just by 2 pixels more, we move to the upper bound of the next layout mode. Okay, so this is where you usually find the bugs. Don't skip that. And with this, I conclude my talk, and I'll be happy to take questions if you have them. Thank you.
Thank you, Adam. Go here first.
With dynamic content, user photos and stuff, I'm assuming there's some tools within the Applitools eye to be able to specifically say these are dynamic and might not be exact.
Yeah, there's an option to ignore regions that are dynamic. You can also mark areas that move around as such, and it's also possible to compare the pages by layout. So if you have a system in production that constantly has different values, different text or images, you can still validate the structure of the pages.
I'm coming.
Can you give an example of this page object callback?
Yes, definitely. OK, so the way we do it is that in .NET we have an action. There is the parallel in many other languages. And it's just a signature of a method that takes a string, which is the description. Okay? And we pass it in as part of the constructor for the base page and all the pages that derive from it. And basically, we have a method that fires this action. It takes a description and just checks if it's not null, and then it activates the callback. Okay? And we call it in our click nav button just at the point where we click the navigation menu and open it up. So it's very simple. It's nothing fancy here. It's just that I didn't have the time to write it down in 30 minutes. That's it.
Yeah, another thing is that, for instance, if you want to automate a web page, sometimes you can see, for instance, if due to some network issue, if you run remotely, the animation on the page can be very slow. Then you have to synchronize on that until everything is fully rendered. Then you can start interaction. And then, for instance, if you trigger some DOM change, then I want to do a visual testing there for every, for instance, dialog pop-up and so on. How to deal with this? Do you have a good suggestion, how to put the visual testing, this kind of when you trigger the event into this flow?
I understand the question. So the interesting thing about visual testing is it makes life simpler for you when it comes to synchronizing with the application. The reason is that you already have the baseline image of what is expected. So you can wait for it. So unlike a traditional functional test where you just test it, and if it's there, it's there. If not, it's not. And you have to code the weights. In this case, what happens when you do a check window is that the SDK actually takes many screenshots, and it just waits for a match. If it doesn't match, it would still try again until some kind of timeout expires. So if it's stabilized after 1 second, it will just move on after 1 second. If it takes 30 seconds, it will wait the 30 seconds or until the timeout expired. And you have a global timeout that's defined, and you can also have a check window specific timeouts if you know that there is a certain place where things take longer. So it's a very easy and natural thing to solve with visual testing. Yes.
All right, thank you, Adam. I think we're out of time.
Thank you.
Give everyone give a hand.